Good morning. In this session, we're going to talk about sampling design. So it's regarding how to take a sample from a defined population. So population, sample, and sampling. So what's a population? Population sample. So what is a population? So population is defined as a set of things or objects in which we have interest at a particular time. So I'm interested in college students. Then the things or objects, in this case, students, are my population. If you are interested in the diabetic patients, then my population interest is all the diabetic patients. So we study the entire population. It's called census. Supposing there are 10,000 diabetic patients in a society, you study all the 10,000, that is called a census. Everybody is counted, entire population. But most of the time what we do, we take a subset of the population. For the population, we take a subset. Then that process is called survey. So population, set of things or objects of interest at a particular time. We study the entire population, the process known as census. But most of the time, we're not able to do that. So we study a subset, it's called a sample. That process is called a survey. So population, we take a sample and study the sample. Now, we often resort to survey rather than census because of limitation of resources, energy, time, and cost. In short, we call it ETC. ETC. Therefore, we resort to a survey, taking a sample from the population. They also test that destroy the subjects that are being tested. Example, you want to estimate life length of electric bulb produced in a factory. How do you test it? You light it on until it fuses. So the objects being tested are destroyed. So obviously, in a production line, you can't be testing all the bulbs being produced. Let's say 1,000 bulbs are produced. Let's say we take 10 bulbs and test them. So the tested products are actually destroyed. So we resort to a sample for this reason, and for specific situations, especially production lines, we have this situation. So we have to take a sample from the population and study this. So that process is called sampling. How do you take a sample? All right, population sample example. In our example, we talk about dialysis patients, and you want to study the depression among dialysis patients. So here population, let's say all the dialysis patients in Malaysia, right? Everybody on dialysis. Of course, you can't be studying everybody because of the ETC limitation. So we take a sample. Let's say sample size of 500, right? From this population. Capital N refers to population size. Small n refers to sample size. So that's a population, let's say. We take a sample of size 500. All right? So this is manageable. We can't be studying everybody unless the agencies or the government want to do it. Even then, they resort to sample. So now, you have two questions. In studying a sample from the population, in taking a sample from the population, study the sample, two questions arise. How will the sample be selected? How will the 500 selected from the 10,000? That's one question. Second question, how big a sample size do we need to say sufficient representation of the population? So that is sample size calculation. So in sampling, there are two issues. One is we are taking a sample from the population. How the sample is selected from the population. Second, sample size. How big a sample size is required. So both must be, right? Both the sampling and sample size must be discussed in your research. Okay, sampling design, how the sample is selected. Sampling design, it can be either probability or non-probability. As you know, the probability, it means chance, right? Selection by chance. So this means selection is not by chance. Let's see more detail. So probability sampling can be either the sampling can be either probability sampling or non-probability sampling. So you're going to look at both and how the sample is taken from the population, what are the limitations, what are the advantages and disadvantages of these methods. Okay, only results from probability sampling is generalizable to the population. Only results from probability sampling. All right, would emphasize more on this. What do you mean by probability sampling? Generalizable. Most of the time, non-probability sampling, the results, it's like gives an intuition of what's happening, right? And most of the time taken as a case study, the kind of things. All right, probability sampling. In this, each person in the population has the same probability being selected. The word random is often used to indicate equal probability, random. Where I say selected a random sample of 5 people from the classroom, random, that means I'm using a probability sampling, right? So what's probability? To calculate probability, we need to know the total number. For example, if there are 30 students in the class, N is 30 capital N population, maybe the chances of a particular student being selected will be 1 over 30. That means every student has an equal chance of being selected. That is the selection is by random. All other selections are not random. So probability sampling, we talk about random. What it means, we need to know the denominator. And then how many you want to select? We just one randomly. So the probability of this person selected will be 1 over 30. Right. To do this, we must sample frame. Just now I say if there are 30 students. How do I know this? I need a sample frame, which is simply a list of members in a population. By taking the class students as my population, I have a class list. There are 30 people in the class. So that's called sample frame, a list of all the students. So probability sampling, random, sample frame. Okay, these jargons are very important. Right, sample frames. So what can be sample frame? Some examples. Class list. The names of say 30 students. It's a class list. Dwelling units is a high-rise apartment. High-rise apartment. There will be 20, let's say, stories. Each level, 20 dwelling units. So 20 times 20, there are 400 dwelling units. Right? Of course, each unit has own number. Example, floor, and then unit number. Right? Example, F118 refers to first floor 18th unit. Similarly, F19-2 may refer to 19th floor second unit. So every unit has a unique number. So that's a sample frame. Passengers in a plane. Each passenger is given a unique seat number. Nobody shares seats. So all the passengers sitting in a plane, we have the sample frame. We know who's sitting where. Pharmacies in Glen Valley. So again, registered pharmacies, each one of them has a unique registration number. So take all the list of all the pharmacies in the Glen Valley. That becomes sample frame. Inpatients in a hospital. Each one is a unique ward on a unique bed. Example, Ward 5, bed number 6. Ward 8, bed number 10. So each patient is a unique ward, and bed number. So these are some of the examples of sample frames. So you want to select one passenger from the plane. So we know how many passengers in the plane. Let's say there are 200 passengers. Selecting one passenger from there, the probability is 1 over 200, and so on. So that's sample frame, right? In these cases, since we are the denominators, we can calculate the probabilities. That is what's important feature of probability sampling. You must have a sample frame, right? Places with no sample frame. Example, students at a cafe, right? We don't know who comes, at what time he comes, he goes there. There's no list of who is at the cafe at the time you went, right? So there's no sample frame. People attending outdoor concerts going on, people come and go. There's no sample frame. People at the airport, some are passengers, some are not, all are mingling here and there. Some came to send off their friends, some came to receive somebody. There's no. Inside the plane, your sample frame. But airport, no. Customers at a pharmacy, people come and go at their convenience. We don't have a sample frame. We don't know who's coming for the day. Outpatients without appointment in a hospital. Outpatient with appointment, we know who's coming. In a day, how many appointments given. Outpatient just walk in, we don't know who's coming. So that's no sample frame. So you may have some situations where sample frame where you can utilize probability sampling. By some other situations, we don't have a sample frame, then you can't utilize the probability sampling. Right. So in such cases, these kind of things, you can't perform the probability sampling. So types of probability sampling. So we have quite a number now, but these are the basic types of probability sampling. Simple random, right? Short form I use SYRS. Systematic random sampling, stratified random sampling. So this can be proportionate or disproportionate to the population size. Later we'll see that. Cluster sampling, right? One stage cluster sampling. We do many stages. We have multi-stage cluster sampling. Especially large populations concerned, this multi-stage sampling is very efficient, right? Okay, let's see one by one. What are they, in what kind of situation we can use that, and what are the advantages and disadvantages of each method. Right, probability sampling. We talk about simple random sample, SRS. So procedure, obtain a list of a sample frame. Example, in a classroom, class list, right? We know how many students are registered in the class, and we know. Give each case a unique number. So our class list is number, let's say 1, 2, n. Decide on the number of the required sample size. Let's say I want n number, small n. Select that many numbers from a table or random numbers or using computer. You're going to select the n number, small n number, from the capital N. Example, let's say n is 30, population size 30. You have to select 6 from there. How do you do this? Randomly. How is done? We can use a random number table or use some computer software. Okay, now example, many computer programs are available to generate this. We're going to use Excel to generate random numbers, right? Example, you want to select 6 students from 30. That means first draw 6 numbers from the 30 and match them against a sample frame. It's the class list. Okay, selecting random numbers using Excel. Right? Okay, first in Excel, any cells, okay, these are cells in Excel, anywhere, just type step 1 equals rand between. Rand between, short for random between. Put an equal sign front. Rand between, bracket 1, 30. 1, 30. 30 is your N, capital N, the number in the population. Next, what you do, you hold this angle, you highlight this, hold, that's called the angle, the plus sign is an angle, hold it and pull it down. Hold it and pull it down. So automatically these numbers are generated. Again, just type this in a cell, hold the angle. When you see a plus sign, that means you're holding the angle, pull down, pull down. How many you want? You want 6. So 1, 2, 3, 4, 5, 6. So that's a number we generated. Next, take these numbers and match against a list. Right? So we have selected 6 numbers randomly from 1 to 30 and match these numbers against a class list so we know who is who. Right, but due to, note this, due to randomness, there's a possibility of the same number appearing more than once. It can be 10 here, the 10 may recur another time because basically they are random numbers. So what do? We want 10 numbers. Normally, we ask for slightly more than 10 numbers. Example, we want 6 numbers. We generate slightly more than 6. Example, 10 numbers. And then take the first 6 non-repeating numbers. Example, let's say this is 10. Already taken 10 there. 16. If this is 10, I ignore this, and I go to next. Right? So I want 6 numbers, some repetitive. Let's say this repetitive, we end up only 5. So normally, we want 6 or so, we drag a bit more, let's say to 10. And take the first 6 non-repetitive numbers. Alright, so that is simple random sampling. We have the list. We decide how many you want. We can use a simple Excel program to create the numbers and match against the list. Right? Simple random sampling has own disadvantages. It has own disadvantages. Right? There's a chance certain fraction of the population goes unrepresented. For example, let's say the class of 30, 14 males and 16 females. Let's say shaded ones are the females. Right? And that's the number we had just now. The number generated, these are numbers. We match these numbers against this list. We can see all the numbers are females. Right? Example 10, 16, 26, 25, 39, and 14. All are females. So in this selection, even though we call it random, there's no representation of males. Okay, this is one of the disadvantages of simple random sampling. Some groups may go unrepresented, or supposing besides the 14 is number 1, let's say. That means only 1 male against 5 female. The sizes may not be adequate. So this is one of the disadvantages of simple random sampling. Alright, that's why we have the other alternative. Next, let's do systematic random sampling. Systematic. Right? Procedure. The population size n is obtained and sample size small n is established. Right? It's called systematic. So what is systematic about here? A sampling fraction f is obtained. Divide the capital N by small n. For example, if the capital N is 1000, sample size I need 100. So 1000 divided by 100. 1000 to 100, your fraction is 10, right? So population is partitioned into n blocks of f items. So in this case, 1, 2, 3 until n blocks, right? Supposing sample size needed is the capital N is 1000 and a sample size of 100. So 1000 divided by 100, that'd be 10 blocks. Block 1, 2, 3 until 10 blocks. Within each block, there will be F number of items. Within each block, F number of items. Then what do you do? Within the first F number of items here, select one number randomly. From the first block, select one number randomly. Let's say it's K. So K, in the first block, Kth one is selected. Thereafter, every block, the Kth item is selected. So by the time go to the nth block, one from each block, you have the sample size required. So it's called systematic. Systematic, we have the sampling fraction. We chose one randomly, that's where random comes in. Randomly within the first block, thereafter follow through the kth number in each block. Right? Let's see an example. Outpatients in a hospital. Let's say we know daily we'll have 200 outpatients. Example, okay? 200 outpatients daily. Very most likely a small hospital, okay? 200. And we want to select, let's say, 20. From the 200, the daily visit, you want to select 20. That's a sample. So what's the sampling fraction? 200 divided by 20, that's 10. Sampling fraction is 10. Therefore, the entire population will be divided into 20 blocks, and within each block, there will be 10 patients. Now, what's the advantage of this? Most of the patients may come early in the morning. As time goes on, the number of patients may be getting lesser and lesser. So even though many patients may come from this let's say from 8 to 9, but we are taking only the blocks, 10 patients first, another block 11 to 20, another block 21 to 30 until right here. So this patient may be coming in the afternoon, but block of them may come in the morning. So you have a blocks of 20 blocks, one patient for each block. I select a number randomly from this first block. How do you do that? Just type in Excel ran between 1, 10. Because there are 10 patients here in the first block. Supposing number selected is the fourth patient. So this block, patient number 4, next block 14th, next block 24th, until the last block 194. So by the end of the day, you'll have the number of patients, the 20 patients we have. You already have 20 blocks. Each block, we're selecting one. Where the word random comes in, one is selected randomly from the first block. Supposing that's 4, follow through 4th, 14th, 24th, 194, and so on. So even this method also has some disadvantage. We call it effect of periodicity, bias caused by a particular characteristics arising in the sampling frame at regular units. Right? Let's see an example. It's a household survey, high-rise apartment. Right? Household survey in a high-rise apartment. Supposing there are 13 floors Each floor, there are 12 units, right? So this times that, that's the number of units we have in this particular apartment. Say in each floor, we want to select one unit. Again, systematic. Each floor, that means 12 units. From 12, you're going to select one, and thereafter, every floor, that number. Supposing 1 to 12, the number selected was 3. So each floor, third unit will be selected. But now, suppose the number we generated between 1 to 12 was number 1. It means every floor, the first unit will be selected. So these units have similar characteristics, being n unit, right? Normally, these n units are a bit costly compared to the middle units, intermediate units. So most likely, people bought this unit must be able to pay more. Secondly, there's no unit after that. So the coherent piece may be different from other units. But still, what if that unit is beside the lift, right? So the randomness is not totally random because the periodicity comes in. So this method also is not, all right? We say simple random method, maybe some may not be selected, right? Suppose in this number of units, I do simple random. There's a possibility all the units selected could be the bottom units or the top units. Again, it may not be representative. To be more representative, we went for systematic. That means every floor I select one. But that first block must be selected randomly. Thereafter, every floor, same number. Some ask, why not every floor select one number randomly? Supposing this 1 to 12, the first floor number 1. Second floor, select one number between 1 to 12. Number 5, maybe somewhere here. Next floor, select again 1 to 12. Number 11, maybe somewhere here. But that is not systematic random sampling, right? In manufacturing, they use it. But in social sciences, we don't have that kind of a system possible. Okay, that's a problem with systematic random sample also. Right. Next, stratified random sampling. Stratified random sampling. This could be alternative to simple random sampling. Just now we saw from the 14 males and 16 females, we selected 6. So happen all were female. So to avoid these kind of things, we rather stratify the population. Example, males and females. Males, there were 14. Females were the 16. Right? So especially when the population is divided into homogeneous subsets. Example, in a university, year 1, year 2, year 3, final year students. Right? Socioeconomic group, lower, middle, and upper. You do randomize, simple random. It may happen all those selected were from the lower. We don't have representation from the higher. So to avoid this, we stratify the population first. Right? Example, you want to see knowledge, attitude, and practice among college students. The year 1 students may differ from year 2 students, and the final year students may differ from the others. So stratify them. Number of units selected. Once you stratify them, these numbers, first year number of students, second year, and the final year, the numbers may not be similar, may be different. And within this N1, select randomly. Okay, let's say the first year student, there are 1,000 students, example. You select, let's say I want, out of 1,000 students, I want 100 students. You select 100 from the 1,000. We can use the Excel, right, function we use this now. So what's the basic difference? As if every layer is simple random. As if every strata is a simple random. But the entire population is stratified by homogeneous subsets. Right? So in this way now, every level of strata will have sufficient representation. Just now, let's say male 14, female 16. Supposing I selected 2 from randomly, 4 randomly, then we have representation of the male and females. Most of software, let's say SPSS, is going to analyze the data. They assume systematic or simple random sampling. The selected data by stratified random sampling then is called a complex sample. So complex sample, the data must be analyzed using complex sample data analysis. That's only disadvantage. These two, the basic SPSS software can use. But here, the procedures you have to use complex samples. Right? So it's a third method for data collection. Right. So in the number selected here, number selected may be proportionate to population, we call it PPS, or disproportionate to the population, DPS. Proportionate to population, disproportionate to population. Right? Example, let's say there are a population of 5,800. I stratify the population in 4 levels. From there, I select 500, which is 10%. 10%. All are 10% from each strata. So take 10%. This is proportionate to the population size. When the strata is a bigger size, more taken. Smaller size, less taken. Time being, just ignore the weights, okay? Now, in some situations, the 10 people from this strata, 10 may not be sizable enough to see variation. Sometimes what you do, from the smaller size here, we take more. This is only 50%, right? This, compare this now, 25%, this 50%. So proportions are different. So it's not necessary you must take proportionate to population size. Supposing only 10 members in this strata, only 10. If I take 10%, only 1 sample will be here. That is not enough. So therefore, there are 2 methods here. This is proportionate. Take the sizes, fix the proportion. Let's say 10%. 10% from each stratum. And that's your 580. Suppose you want more representation here, we feel not enough. Then use disproportionate. Right? Can we simply put a number? There's another question. Of course, I want a sizable number. All this can be corrected by using appropriate weights in the analysis. This weight 10, what does it imply here? 500 people represent 5,000. 500 represent 5,000. So each person represents 10. Over here, 10 people represent 100. So each person represents 10. The weights are all the same because they're proportional to population size. Supposing here now, they're not proportional to population size. I select 50 people from 100 So each person represents 2. If I take 100 people from 400, then each person represents 4. You can see differences in the weights. So when you do this kind of selection, you must be careful with the weights. These weights must be incorporated in the analysis. These are not so much. You can still go ahead, but here the analysis is more complex. Then why you do it? I would say this better than this because better representation, especially this start time very small number, we need to have higher proportion. We can't do proportional to population size, right? Okay, that is stratified random sample. Next is class sampling. Class sampling. Population divided into classes, usually along the geographical borders. Then randomly select classes. Study all units within the sample cluster. Example, let's say in a rural district, there are 12 villages, right? Of course, villages are mostly along the geographical boundaries, rivers, right? Hills, whatever it is. So let's say we have 12 villages. Our resources can only take five villages because of our ETC, 5 villages only. So what do? On the 12, we select 5 villages randomly. Example, we go to Excel, just type there equals rand between 1 to 12, right? And then pull down 5 villages. So these are the selected villages, right? Select the 5 from the 10, from the 12, from the 12, and everybody in the selected villages will be considered for the study. Again, it's a big area. We can't cover the entire area. We know the 12 villages. We know the village head and so on. We know who's in the village head. We know who are the people in the village. We can cover only 5. So draw randomly 5 numbers from 12. This is the 5 selected. So within the selected 5, we study everybody. So that's called class sampling. This also has some disadvantages, right? So whatever method you're doing, none is perfect. One can be better than the another one in one situation, but not in another. So you must decide what is an appropriate sampling design you're going to use in a study. All right, next, multi-stage. Now, all the methods, this is known to be very efficient. Example, I want to select students in a district, in a state. Let's say state of Selangor. I want to study Form 4 and Form 5 students in our local schools. So there are 8 districts here. In my resources, I can only cover 4 districts. So 1 district. Cover only 1 district. So from the 8 districts, select 1 district randomly. Let's say again, district number 4 selected. Among the 8 states in the 8 districts in the state, let's say district number 4. So district number 4, they also have urban and rural schools in the particular districts. They don't want to lose out. I can't simply go to urban schools only. So study the schools in that particular districts. Say there are 5 urban and 3 rural schools. The 8 schools in that particular district, 5 urban and 3 rurals. Again, I can't be going all the 5 and all the 3 schools. Let's say I select 1 school randomly here, school A, let's say. 1 school randomly here, let's say school B. So it's a school selection. All the red boxes we are selecting. randomly, right? So we have a school weight will come in. Once inside school, you go to Form 4 and Form 5. Form 4 and Form 5. Form 4, we don't know, school to school may be different, right? Supposing there are 3 classrooms, we can select all the 3 classrooms. There are 10 classrooms, you're going to select, let's say, only 3 classrooms. Then the classroom weight comes in, right? So now, from the each school selected, Form 4, Form 5, I'm going to select 3 classes here, 3 classes here, right? And so on. So within each class, let's say the average 30 students, I'm going to select only 10 students. Within each class, I'm going to select 10 students. By doing this, I managed to have the 120 students needed for my study. So the bias is very much reduced. So happened this particular district, could have been this district, right? Our bias is very much reduced and we're able to go top down to that student. So what I need is a sample frame of the students in each classroom. That's all. Each selected classroom, I need a sample frame. Here, there could be 30 students in this class. Here, there could be 40 students in this class. So I draw randomly 10 students from each class. So these are the ways to consider. I don't go detail of this. But looking at this, right, many surveys in the world that are doing this kind of multi-stage. They're able to capture more representation of the population at large, right? So that's multi-stage. So these are the probability samplings. But there is difficulty in probability. There's difficulty in probability sampling as well. Sorry, this probability sampling. The probability sampling have to trace the selected individuals. Let's say one individual selected from the particular village. It go and trace it. Suddenly goes missing. So we're not able to capture. But probability sampling with a poor response rate does not give a good representation either. Let's say from that compound, from that particular village, and we'll suppose select all the villages. Supposing only 2 of them responded. Again, that's not a good representation, right? Sorry, this is difficulty in probability sampling, not probability sampling. We have these issues, right? So even though only probability sampling, the results are generalizable, still there are weaknesses within the system and also the response as well, right? So there's no one technique that's perfect, but you want to make it as representative as possible. Okay? Now, non-probability sampling. So when you use this, always it's not possible to undertake probability sampling. Why? We may not have a sample frame. For example, commuters using public transport, you don't know who's coming today. People who are attending football match, you don't know who's at the stadium. People who shop in a shopping complex, you don't know who is the complex at that particular time. All these situations, we don't have a sampling frame. Therefore, probability sampling cannot be done. Only alternative is non-probability sampling. Even customers at the bank, we don't have the list, but the bank wants to do the survey. They have the list. They can do probability sampling. But as an independent party, you want to survey the bank customers, we won't get the sample frame. It's unethical for the bank to give the sample frame to the researcher. So no choice. We have to go for non-probability sampling, right? So non-probability sampling, cheaper, Used when sampling frame not available. Population so widely spread. Classes also may be difficult to move from one village to another. So most of the time is used in exploratory studies, right? Exploratory studies to find out what's happening. So most of the time it's good for generation of hypothesis. Some researchers may be interested only in obtaining idea wide range of responses. The person may not be testing anything. For example, he's not interested in determining the prevalence of diabetes and the factors associated. Maybe not. Just want to know on the past how many people are depressed. Idea. So that's where the non-probability sampling can be used. But unfortunately, most of the social sciences, masters or PhD students, they all use non-probability sampling. Why? They claim they don't have a sample frame. How to do that then? So again, you mention in a method section, what sampling was used. I use non-probability sampling. Justify why non-probability sampling. Right? Okay. Disadvantages. Data collectors may choose only those whom they like. Right? Ask them go and study. Right? Go and study 10 villages. They just go there. Whoever their relatives, friends, they study that. So that's not random. That's not representative. Sample may not reflect the population. Suppose you go to selected villages, but you go to the village, only the village which is easily accessible, right? Again, it does not fulfill our criteria, right? Impossible to estimate accuracy. How accurate your sample is, most of the time is bias, right? The bias is very high in non-probability sampling, right? So generalizability is questionable. So type of non-probability sampling, what types do you have? Again, so happen you have to choose non-probability sampling. You have to describe at least how the sample was selected. It can be quota sampling, purposive sampling, convenience sampling, snowballing, right? These are the main types of sampling, non-probability sampling we have. Okay, let's see each one. Convenience sampling can be used when you simply stop anybody, right? No choice. Let's say go to cafeteria, right? With your student sitting there, not having food, chatting with friends. You go there, okay, I want to study, right? At convenience. You can do in the street who's prepared to stop when you wander around a business center, shop, restaurant, theater, anywhere, right? People you meet, ask them whether they're willing to answer the question. They're willing, we say consent taken, and you have a questionnaire, we ask them to fill the questionnaire. Or interview, we just interview them. It's convenience sampling, right? At your convenience. Example, you went to the commuter station at 12 noon because that's your convenience. You can't decide who comes at 12 o'clock, right? You go 12 o'clock, who will be using the commuters? Mostly housewives, those go shopping. You may not capture the actual problem people have, especially during the rush hours. But you went 12 o'clock because that's your convenience. So again, whatever information you gain may not be accurate, could be biased, right? So researchers often tempted to use random. A student may say, I went to the railway station, selected 10 passengers randomly. We know random means must have a sample frame. Who gave you sample frame at the railway station? Who has a sample frame for the railway, the passengers at the railway station? Nobody has. So don't use the word random when you are doing non-probability like convenience sampling. You describe how the sample is taken, but never use the word random, right? Should avoid using the word random, as I mentioned just now. Don't use the word random. Describe. Purposive sampling is one which selected by the researcher subjectively for some reason. Right? Example, you want to study the lecturers by the public universities. You selected University of Malaya. Ask why University of Malaya. You may say, oh, that's the oldest university, first university in the country. If that is okay, fine. Purposive sampling. That sample was taken purposely, the reason being the oldest or the first university in the country. Right? The researcher attempts to obtain sample, again, appears to him to be representation of the population. How representative is still questionable. But he justified that's the first university, oldest university. That's the only reason we have. Right? Try to ensure the range from one extreme to the other is included, especially when you purposive sampling. Right? So there must be expertise in selecting this subjectively. So some of the, let's say, the clinicians may select certain group of people purposefully based on subjectivity. Right? So the sampling may not be random. They select the patient because they seem to have certain characteristics purposefully. All right? Like in vertical polling, certain districts are chosen because the pattern as a past provided a good idea. They might do a study at one particular location because that particular, they are the kingmakers that makes a difference in their electoral outcomes. So most of the time, that particular whatever constituency that makes the swings the vote, people may want to go and study that because purposely they decide purposefully, right? That's purposive sampling. Quota sampling. This quota sampling, like stratified random sampling, we still stratify the population, but no randomization, right? At least it reflects the population at large, right? Say you want to study 200 people from a large population proportionately. We are interested in age group, all the age groups must be covered. So estimated, these are estimated, we know there are 20% of people are in this group, 35%, and so on. Right? From statistics department, they mentioned that in this group of people, we have this breakdown from the population size. Right? So let's say proportionally, we know roughly 20%. Right? We take a sample size, you want 200, right? 200, 20%, 35%, right? So that is proportionate to population size, but no randomization. I want these people, I want 40 of them in this age group. First come, first serve. I keep on gathering people in this age until I reach 40. Then disclose. Of course, simultaneously, we're selecting people all over. As long as it reaches that number, we stop. So here, how does it differ from stratified? There's no randomization, first come, first serve basis. But among the non-probability sampling, they seem to be at least representation of the population is there, right?